Hello everyone, today in this video we are going to do the physics 7th chapter, that is sound. First half already came in the first semester, so we will be doing from the second semester part, that is from natural vibrations or free vibrations. So number of one oscillation in 1 second in vacuum is known as natural frequency. So what is known as natural or free vibrations? So these vibrations will be taking place in vacuum and in the absence of any resistive force or external force, and vibrations will continue till the infinity, and so amplitude will remain same throughout complete vibrations. So its graph will be like this: displacement and time, and its amplitude will be remaining same completely. And then there are some examples where this was a pendulum, length was L, and this what we say bob's the mass will be gram. So we know that for what we say frequency is equal to 1 by time period, and time is equal to 2 pi root under L by G. These were the formula earlier we have learned. So what will be natural frequency? 1 by T. So 1 by 2 pi root under G, L by G will be, then it will be reversed, it will be divided, then it will get 1 by 2 pi root under G by L. L will be coming down and G will be going up. That's it. Now what is stretched string? So stretched string, in that we have taken the what we say length. So in this stretched strings, I string has been taken and that it is tied from the two ends, and because of the tension it has plugged, and so it will be showing the what we say vibrations. And here we have taken and tied, it means here we have divided it by the 2 and here by the 3. So what will be the its midpoint? L by 2. L by 2 means it will be a L by 2, and this will be divided into 4 parts. So L by 4, and midpoint of it, this will be L by 6, and amplitude will be A. Here will be A by 2, and here will be A by 3, and frequency will be F only, and this frequency will be 2F, and frequency of this will be 3F. And so what will be it will be known as first harmonic, fundamental tone, and principal tone, and this will be second harmonic, first overtone, and this will be third harmonic and second overtone. Third one is natural frequency of stretched string. We have taken and it has a string and it is stretched, and now here is the length and here is the lambda by 2. It's what we say we have divided it into 2 parts, we have halved it, so lambda will be 2L. Now its formula we have learnt earlier that V is equal to F lambda, means V here is the velocity, and we have already also known that V is equal to T by U. So F will be F equal to, we can write V by lambda, and then so F will be 1 by 2L root under T by rho pi r square, because we have we know that mass is equal to density is equal to mass by volume, so mass will be rho into volume of the cylinder pi r square. We have taken here the cylinder, and so it will be U, means M by L we can write the U, and so it will be rho pi r square. U in place of U, now we can write the pi r square. So T by U, here will be T by U. V in place of V we have taken the T by U, root under T by U, so T, and in place of U we have written rho pi r square, and so the formula came 1 by 2L root under T rho pi r square. And friends, these are not that much important, so don't worry that much. Important are this one: natural vibration, free vibrations, and then damped vibrations. Just remember the formula. And loudness will be depending on the amplitude, shrillness will be frequency and pitch, and wave sound speed will be remaining same. Now what is damped vibrations? The vibrations which is taking place in air in the presence of resistive or external force, and vibrations will end after some times and amplitude decreases with the time, are called damped vibrations. Just learn these points. And its graph will be like this. Amplitude keeps on decreasing with the time, displacement and time. With the increasing of the time, the displacement decreasing. Now the forced vibrations. The vibrations the vibration of the body takes place by external periodic force, and its amplitude is very small, means it's small, very, not very small. And now the resonance. It's the special case of the forced vibration, and if frequency of natural vibration will be equal to frequency of the external periodic force. So natural vibration, frequency of natural vibration will be equal to frequency of the forced vibration, and its amplitude will be increasing in amplitude. Now characteristic of the sound. There are three types characteristic of the sound: loudness, pitch and quality. And now loudness, it will be measured in the phon or decibel, dB. So what is loudness? Two sounds can be differentiated, both of having same quality and pitch, and also of same instrument or sources, but at different level. So what are the factors affecting the loudness? Loudness is directly proportional to the amplitude. A square means amplitude per square, amplitude square, and distance from the sources also. Loudness is universally proportional to the distance from the sources. Density of medium, directly, if we will increase the density, then the loudness will be also increasing. Surface area of the vibrating body, if surface area we will increase, then loudness will too increase. And then the presence of resonating body. What is subjective loudness called? So there are some subjective loudness, that like faint sound, pin drop, that is 0 decibel. Whispering, when we whisper in our classes, that sound is of only 30 decibel. And then normal conversation sound is always 50 decibel, and jet's plane sound is always 140 decibel. And above the 120 decibel sound all are called noise. What are now intensity? Intensity is both objective and the measurable. Energy passing from unit area in unit time is known as intensity. So intensity is equal to unit energy passes from the unit area in unit time. So energy by area into time, that is joule by meter square second. So work by meter square. So in small intensity is 0 decibel. And what is 1 decibel? How can we describe 1 decibel? Change in level of loudness when intensity of sound is increased by 26%. So when the change will be there will be change in the level of loudness and intensity will be rising by 26%, then we can say that it is the sound of 1 decibel. Now what is pitch? Pitch is also measurable and objective, but the loudness were only the subjective. But these both are objective. Objective means they all are fixed, but in subjective that can be vary also. So now pitch, measurable and objective. Differentiation of two sounds of same loudness, same instrument but of different frequency. Pitch is the frequency depends on the pitch. So low pitch has some examples of the low pitch and higher pitch: bass, whooper, graver, man; treble, shrill, acute, woman. These have the higher pitch and these have the lower pitch. Pitch depends on the frequency. When there will be high pitch, then frequency will be too high. Its graph is like this: time, displacement, frequency. Now some example is pitcher. For our pitchers, explanation of pitcher is here. A tube has been taken and here the slowly water droplets has been put it. So as water droplet starts filling, length of the air decreases in pitcher, so frequency rises, and so the pitch is high of the pitcher. Now we have compared their three graphs. In A we have taken the only frequency was 2, no sorry, yes, frequency was 2 and amplitude was this, and this, here the frequency is 3, 1, 2. Here frequency was 1, here frequency was 2, but amplitude was same also, but frequency was 2. And here the frequency is 2 but the amplitude is different. So we have compared from A to B. A to B frequency differs because here is one frequency only, here 2, and amplitude was same, one completely, this were of same distance, same amplitude. So loudness will be same because amplitude same, so loudness will be same because loudness depends on the amplitude. And when frequency in B frequency is high, so it will be shrill. And comparing A to C, amplitude will be differing because its amplitude distance is different, and C will be having less loudness because amplitude is equal to loudness, means loudness depends on the amplitude. So its amplitude is less, so its loudness will be also less. And A and C will be having same frequency, so it will having the same pitch because both having the same frequency. Now came the last part, that is quality or timbre. Two sounds of same loudness, same pitch but from different instruments can be distinguished is known as quality, means quality of the instruments, or that is also known as timbre. So same loudness, same pitch but of different instruments. I have drawn the graph like this. Violin will be like this, piano like this. Now amplitude is same, so loudness will be same because amplitude is same for everyone, and frequency is even same, so pitch will be also same, but waveform is different. So quality and or timbre depend on the waveform. So waveform is different, so quality or timbre will be also different. And now both noise and music are subjective, but how can we differentiate it? Noise will be irregular, harsh, forming the wave. It forms the wave irregular, harsh, disturbances, discontinuous and non-periodic and unpleasant, and it will be above 120 decibel, and it will be regular, smooth, continuous, periodic and pleasant. So it will be between 10 to 30 decibel. This will be soft, light, but it will be harsh. And you can see the graph here.